Welcome. From this lecture, we are going to start a new concept in power electronics, that is rectifier. Now your question will be, what is rectifier, or why we are studying rectifier? In power electronics, rectifier is used to convert AC to DC. Now AC stands for alternating current and DC for direct current. As an electrical engineering student, we all know this concept. So rectifier converts an AC quantity into its DC value. Now your question will be, why AC is converted to DC? What is the objective of converting AC into DC? See, first is the traction purpose. Now what is traction? Traction means driving or pulling a heavy load. This is traction. So whenever we are using a crane, we are hoisting a heavy load through the crane. Next, if a locomotive like this is running, then it is pulling also a heavy load. To pull a heavy load, all we need to have a high starting torque. This is a very important concept. Anything, a heavy load, if you want to pull, then you need to give an initial high torque to get that initial momentum, and that is only possible whenever we are using a DC series motor. So if you are using a DC series motor, then we need DC current. For that, AC must be converted into DC. Clear? Next is, many industrial mills like paper mills, rolling mills requires DC electricity for its function. Next is, many of us have heard about HVDC or high voltage DC transmission. What are the advantages of using this high voltage DC transmission is, we need a phase and neutral to transmit the electricity. This is phase and this is neutral. In three-phase system, we need to have 3 conductors for 3 different phases. So in HVDC system, this is a safe in conductor material, so it is more economical. Next is, HVDC system is free from reactive power losses. We never find Ferranti effect in HVDC system, where the receiving end voltage is higher compared to the sending end voltage under no load or very light load condition. It is being used in transmitting power in nowadays for better quality power transmission. In general HVDC system, the voltage is stepped up to 1500 kV. Whenever your power is constant and you are increased your voltage to such high level, then automatically your current will decrease. Whenever the value of current decreases, there is lesser amount of copper losses. So that is another advantage of using HVDC system. Many hand driven tools like grinder or a blender, DC motor is used. So you need DC current to run these tools. So that is another requirement for converting AC into DC. Now let us discuss about the history of this rectifier. Usually at the beginning of 20th century, ignitron, which is a voltage controlled gas filled tube, were used for rectification. This is the ignitron tube. But slowly the entire system is switched into Thyristor or SCR. Now, what is Thyristor? How does it work? What is the functionality? All I have discussed in the previous lectures. Watch that lectures. Then I will give that in the description box below. You can watch and you can clear the concept of Thyristor and its working principles. So we have turned into these thyristors or silicon controlled rectifiers to perform our rectification process. Now your question will be, why thyristor? Why not ignitron? Now the first advantage is it has got an easy firing technique. Means we can use IC chips or microprocessor units to fire the thyristor. So we can perform this firing process in less expensive way. That is an advantage. Next is thyristor can operate both in rectifier and inverter mode. Now how? Whenever your firing angle is greater than 90 degree, then your rectifier unit can perform also as an inverter. Now what is firing angle? What is the purpose? I will all discuss this in the next lecture. Sometimes when you are performing a braking procedure or regenerative braking, then you have to send back power from DC motor to supply, and that is only possible when your rectifier unit starts to operate as an inverter mode. Next is thyristor requires a very less maintenance, so you don't need to think a lot about its hazards or maintenance problems. So that is another advantage. Next is no separate commutation circuit is required to turn off thyristor or SCR. Commutation means turning off. So in AC system, a reverse voltage appears across the thyristor because we know in AC system it is always in alternating mode. So this is the negative voltages that appears across the thyristor, and when we need to switch off the thyristor, then we don't need to give any separate commutation circuit, and we can turn off the thyristor pairs for full wave rectification or a single thyristor for half wave rectification. So again, it's economical. So these are the few reasons why the rectification process has switched on from ignitron to SCR. Clear? Now let us discuss about the classifications of rectifier. There is separate types of rectifier exists in power electronics. First is half wave rectifier. Next is a full wave rectifier or full converter. Next is semi converter. Like this, we use it for the conversion of both single phase and three phase rectification. I think we'll all know that half wave means when the rectification occurs for only the half cycle, like this. This is half wave rectification, and for full wave we get rectification for the both positive and negative half cycles. Clear? So according to our requirement, we use this half wave rectification or full wave rectification using this rectifier or converter. So I think the concept of rectifier and its objective of use, and as well as the advantage of thyristor over the ignitron tube is pretty clear to you. From the next lecture, we will go in deep about the discussion of types of rectifiers. Thank you.